We're moving into a section of the course where we're going to be talking about a lot of statistics or parameters. So what's the difference? Here you'll see that when we look at information taken from a sample, what we're doing is calculating sample statistics. If we're looking at information taken from the population as a whole, then we're looking at calculating population parameters. So when we're doing our statistical inference, which is where we're moving into this next section of the course, what we're doing is looking at each of those sample statistics as being what we would call a point estimator of the population parameters. So by that we mean sometimes it's not feasible for us to calculate, say, the mean of the population. So if we take a sample from the population and we calculate the mean of that sample, well, that mean of the sample is an estimator for the true population mean. And since we're estimating it and it turns out to be one data value or one data point, it is a point estimator of the population parameter. So let's take an example here. If we're looking at a population, which might just be our alphabet, you can see that the population is circled here in the light blue oval. That's everything that there is in our alphabet. Right, so if we run calculations on the alphabet or our population, then what we're doing is finding the mean, the variance, the standard deviation, and those will be listed in the Greek alphabet. So you'll see them down here on the bottom as mu for the mean, sigma squared for the variance, and sigma for the standard deviation. Don't worry, because we're about to explain all of those in the following slides if you haven't seen them before. Not everything is easy for us to see everything in the population. It's not always possible for us to calculate things from a population, either due to time or money constraints, or by the fact that our population might be infinite. If that's the case, really what we're going to do is take a sample from that population. And so here you can see a sample selected in the blue box, where I picked out 4 letters from our alphabet. And what you want to do, and what's important, is that every time you draw a sample, each of the elements in that sample should have the same likelihood of being drawn in order for it to be a true random sample. If we run our information off the sample, so if we take the mean, the variance, and the standard deviation from the sample, then what we're doing is we're seeing it displayed as what we call x bar, that's the mean, s squared for the variance, and s for the standard deviation. The reason why we have 2 different sets of symbols is to help illustrate and keep the difference between what is a population parameter and what is a sample statistic. You'll see that those sample statistics are, in fact, point estimators of the population parameters. Hopefully this helps to give some context and explain how everything fits together. Do be sure to email anytime if you have any questions or confusions.